speaker is Damian. Damian works for deevio, a startup in Berlin, and he's going to talk about deep learning, real-life experiences from more than 3 years.
Exactly.
Damian.
Thanks a lot for the introduction, Anne. And thanks to everyone for being here. So today we want to talk a bit about the deep learning and real-life experiences. My name is Damian, I'm the CEO of deevio, and we automate visual inspections. Before we go into detail about deep learning, I want to share a different real-life experience that we get all the time we're in factories. And that is that factories still look like this. So even though we have fantastic technology out here, great companies, at the end of the day, and especially at the end of the production line, there's still a lot of processes that are still done manually. So it doesn't matter where we go, you always find people who do nothing else but check the quality of the products before they're getting shipped. And as you can imagine, it's a very tedious job and it's prone to errors. As you know better than me, machine vision has been around for years, for decades, but there's still a lot of cases that the current traditional rule-based machine vision can't solve, especially when it becomes about very flexible or variable defects, like scratches on surfaces. They're often very hard to spot and to put into a rule. And this is exactly where we think that there's still a sweet spot for something else, for something not on a hardware innovation, but something on the software innovation. And that's exactly why we built deevio. What we do is we developed a deep learning toolkit that comes with typical classifications. Short break. Okay, I think it's laut genug?
Yeah.
Okay, I think it should be loud enough. I'll talk a bit louder. So what we did is the deep learning toolkit. So we derived the most common and most important features you need in deep learning, like classification, segmentation, or object detection, and put all that into a toolkit that we internally use and with which we can solve use cases in a very short amount of time. But just the software is not enough to automate processes. And that's why we developed the AI box, which we developed together with a company that also exhibits here. It has a GPU inside and can be plugged into multiple cameras, camera agnostic, so we don't really care which cameras we use. The inference happens on the edge, and then we give the results back to the PLC and do is make sure that it really runs in production. And with these two things, there's two options that we do for our customers. The first thing is we integrate our software into a new machine. So given that the quality control is still manual, then we can also help in choosing the right camera, choosing the right light to get the best possible image. And then we automate that together with the customer, together with the end customer, or together with a network of machine builders who's doing the automation around it. Or the second case, which we see a lot in the industry, is that machine vision systems are already out there, but either they produce a high number of false positives, so surface scratches are thrown, like good parts are still thrown out because the camera is too strict, or that the companies want to add new features. Like, for example, they were always only measuring things, and now they also want to check the surface. And that's where we come into play. We can connect our box to an existing camera system, have the inference run on the edge, and then give the result back, so you can still use the hardware that you have. Because what we see, it's mostly not a problem on the hardware side, but on the software side. And all this is not just a vague concept and the fancy idea that comes into place at some time, but this is something that actually really adds a lot of value already. Here's 3 example projects that we've done and the savings that we achieve per line per year. For example, in pharma, we are retrofitting a system, and we've been able to lower the false eject rate so heavily that we achieve a savings of 300,000 euro per year. Same in automotive, and then third case in precision tooling, where we installed a new system together with a partner, which generates savings of 100,000 euros per year. And let's look into 2 of the cases a bit more in detail. So, in pharma, we're working together with an end customer, with a big pharmaceutical company that has already this machine that you can see here. It's from a well-known machine builder. They have a typical machine vision system that checks for some defects and measures. But there's one thing it does, and that is you have a defect that is like a black dot, and this defect has to be thrown out. However, this black dot looks very similar to the edge of a water drop. So the traditional machine vision system looks at the water drop, sees that it's darker than the rest of the image, and throws it out, and says it's not good. However, this is not the case. And our system is able to learn to differentiate between water drops or bubbles and defects and particles in pharma. We actually retrofitted the system, so we took our AR box, connected it to the cameras, and had it run for 3 months, collecting the data to make sure that the deep learning system in pharma actually has a massive impact. So within 3 days, we've been able to reduce the false eject rate from more than 5% to less than 1%. The next thing we want to talk about is the precision tooling. So what we've done here, or the main challenge that we have, is that precision tools come in very different shapes and sizes. So the customer we have, they have a product variation of hundreds of different parts. Some are longer, some are smaller, different diameter, different amount of cuts. And here we build a system that works for all the different variations. So one system for hundreds of products and one algorithm for hundreds of products. What we do here is we have a matrix camera in the front that checks the top of the precision tool and the line scan camera on the side. And we train a model on the images, about 100, 120 example images, and we're able to actually put it into production. So having all this said, there's a couple of things that we learned along the way that are the key success factors in our point of view for deep learning in machine vision. First thing is the data quality. So of course, the technology is really good, but without a good image, it's nothing. Then the second thing, and I think there was also some talks about that later yesterday already, is the data label quality. It's extremely important that you mark the defects and that you're really precise and that you don't make an error there. Otherwise, the system will not be able to learn anything. And the third point is related to that: review the labels continuously. Before you have a new training data set for an iteration, review them all the time. And then sometimes combine deep learning with rule-based vision. Especially in pharma and also in other applications, it's really important to continue to use rule-based machine vision for measuring or for different other checks, and combine it with deep learning where it makes sense. So, and this is exactly what we do at deevio. So what our edge is that we don't only do a deep learning software, but we also have the automation know-how, and we can actually implement it into a machine and actually make sure that it's not just a nice software, but that runs in the factory, runs 24/7. We have use cases where we are at 20 milliseconds per image. We have use cases where we have to detect defects that are at 10 micrometer size. So the technology is very flexible, and we know how to make it run. So thanks a lot. Please visit us at our booth. It's right across here. And happy to get your questions. Thank you.
Thank you, Damian. Questions to Damian? Are there any? Oh, and please, all of you, you are invited to ask questions by using the chat. Klaus Henning, you have a question, please.
Yeah, I would like to know more about your business model. So how do you gain, and is this the hardware or services or mixture?
Yeah. No, it's not a fully service model. It's two factors. The first thing is a setup fee. So we charge for the hardware and for an initial setup, because especially if we have to connect it to machines, to a PLC, there's always a bit of standard work or custom work you have to do. And that's where we also charge for in the beginning. And then once everything is running, we work with a yearly license model, where it's also included that we retrain the model and make sure that it actually stays on a good way, and also educate and consult the end customer with labeling. Because as we all said, as I think we're not the only one propagating this, it's extremely important.
Thank you.
Okay, thank you.
Damian?